talk about our comparing distributions. Okay, comparing distributions. So this is the last thing that you guys are going to kind of learn in this paying attention to everything, or getting deeper and more analytical. Okay? So what I want to teach you, because you actually use socks, so I want to teach you what you need to do when you are comparing two sets of socks. Okay? So here's what you do. When you compare two things that you're describing, you need to use comparative language. You need to make sure that you are saying things like more than, the first box plot has a median that is more than the second box plot. Something that is less than this. The other one is greater than. Make sure you are using comparative language. Here's one thing that is very sad, but it happens. People will come and they'll be asked to compare two distributions, and they'll say, okay, for the first box plot, here's all of these things for the first box plot. And then they'll say, okay, for the second box plot, here's all of these things. And they just say, they describe each one individually, but they never connected the two by comparing them together. And in this case, up here, all of these look real nice, but that would be completely zero credit. Okay? Because the question is not what are the things on those two, it's to compare them. Alright, so whereas is a word that gets you in trouble because sometimes if you say the center, you can say the center on this one is like 15, whereas the center on this one is 17. Have I connected those two together? I said the center on one box plot is 15, whereas the center on this one is 17. Have I compared them? No. So do not steer clear of saying whereas, because that's just comparing them separately. No, and so now you want to be specific also. Be specific and use specific values for your center and spread when you are comparing. All right. Now, if you are comparing a box plot, you have the ability on a box plot to say center, or whether something is symmetric or skewed. And we discussed that here. Remember how I said on a box plot, you can tell that this one is slightly skewed to the right. Okay? But can you tell if this is a set of unimodal or bimodal or multimodal data? No. You cannot tell how many modes there are by just looking at a box plot. So keep that in mind. You can't describe it how many modes. All right. We also want to compare percentiles. For example, down here, one thing we might say is this. Look. The top, how much percent is this up here? Thank you. It's the top two quartiles. So this is the highest 50% of this 1 cup box plot. It is larger than the bottom 75%. Okay, so you see how I'm comparing some percentages, or I could say is, anyway, so the top 50% of this one is larger than the bottom 75% of the second one. So that's another thing that you need to consider. It's comparing their percentiles, that you may be asked to do that. Alright, now, histograms, stem plots, and dot plots. Oh, by the way, on box plots, you only just talk about the median and the IQR. You don't do mean and standard deviation on box plots. But on histograms and stem plots and dot plots, You actually would prefer using the mean and standard deviation if you have that ability. However, only use mean and standard deviation if you can verify that the data is symmetric. Because if the data is not symmetric, then the mean and the standard deviation are being messed up. They are being altered. So in the event that you have skewed data or outliers, then what should you use? Medians and IQRs. Okay. All right. And by the way, on these here, you do have the ability, you can tell how many modes there are on a histogram and such. You can tell how many modes there are. Okay, very good. So let's go with this problem here. This is an actual AP free response question in 2008. So let's take a look at it. To determine the amount of sugar in a typical serving of breakfast cereal, a student randomly selected 60 boxes of different types of cereal from the shelves of a large grocery store. The student noticed that the side panels of some of the cereal boxes showed sugar content based on 1 cup. So some of them showed the serving size as 1 cup. And others showed the sugar content based on 3/4 cup servings. Have you ever noticed that? Have you ever looked at even soda cans? One of them it says only 100 calories per serving. Okay, well there's 8 servings in there, you know. So, or whatever. Pay attention to the serving size, because that's how they will shrink that serving size down, so they make you think that it has lower carbs, or it's healthier, lower fat content, or whatever. So, to investigate this question, the data were separated into 2 groups of different size servings on their side panels. Oh, where is it? One group consisted of 29 cereals in the 1 cup serving size, and the other was 31 boxes in the 3/4 cup serving size. The box plots are shown below. Okay. So right off the bat, I already am I see that there are differences between them. So the first question says to write a few sentences to compare the distributions of sugar content per serving for the 2 separate sizes. Okay, you don't have room on the bottom of your paper, so you can flip to the top, and I'll keep this up here while we go over it. So here we go. When we describe a distribution, we describe it with our what? Socks. So we're going to describe and compare these 2 box plots with our socks. What does the first S stand for? Shape. Okay, so what could you say about the shape of these 2, comparing the shape of these 2 items? Okay, the 1 cup data is more, what? Skewed left than the 3/4 cup data. And the 3/4 cup data is more, what? Symmetric than that. Okay, so let's do that. The 1 cup data is more skewed left. And do not leave that more hanging out there. It's more than the 3/4 cup data. If you just say more, then I'm like, more than what? More than your shoe? I mean, I don't know. More than the 3/4 cup data. No. The 1 cup data is more skewed left than the 3/4 cup data. Okay? And I could actually probably leave it at that. But by the way, you also could have included the 3/4 cup data. Data is, yeah, it's kind of like a bracket. Because you don't have to probably include this other one, but you could, is more symmetric than the 1 cup data. Okay, so that's, a thorough statement there. All right, what do you have to say? So we have covered shape. What's next? Outliers. So what do you have to say about the outliers in these problems, or in these 2 box plots? It doesn't appear that there are any, because they do not have any dots drawn. So I could say neither distribution or box plot, whatever, neither box plot appears to have outliers. Should I say neither box plot has outliers? That's a little too definitive, because what if they didn't tell us specifically that this was a modified box plot, which shows outliers? But anyway, neither distribution appears to have outliers. Now, could I probably compute that? Could I compute it? I could. I could do 1.5 IQRs and add it to Q3 and stuff. So, all right. What's next after outliers? Center. What center would you compare with box plots? The medians. So, what do I want to say comparatively about their medians? Data. Okay. Okay. How about, let's be specific. How much higher is it? Okay. All right. So here we go. The 1 cup data has a median that is 3 grams higher than the 3/4 cup data. And then I can put my little 13 grams versus 10 grams. We are being specific in the values. Alright? So I have talked shape, I have talked outliers, I have talked center. What's left? Spread. What spread would you reference with this type of display? And no, probably not. No standard deviation. IQR is what we are more interested in than even the range, since we can tell the IQR is our typical method of spread. So I'm going to probably notate that this IQR is how much? From 15 to 4, it looks like it's 11. This IQR from 12 to 8 is 4. So what do you have to say about the 1 cup data? It's much more varied, right? How much more varied? How many more grams varied? Okay. So the 1 cup data has an IQR that is 7 grams more varied than the 3/4 cup IQR. And then guess what I'm going to do next? Put in parentheses 11 grams versus 4 grams. Okay, so you have not described 2 separate distributions. You have connected the 2 in every single one of the bit of information. So, let's see what happens next. Don't you think it would make sense to compare 1 cups to 1 cups instead of 1 cups to 3/4 cups? So, the student decides to remedy that. So the student decides that instead of a comparison of sugar content per recommended serving, it might be more appropriate to compare sugar content for equal size servings. So in order to do that, how do you turn a 3/4 cup piece of data into a 1 cup piece of data? You're going to multiply each piece of data in the 3/4 cup set by 4/3 to make it into comparing 1 cup to 1 cup. All right. So now, question. Based on our transformation information on Monday, what would multiplication by 4/3 do to the data in the 3/4 cup category? No. Okay. 4/3. It's going to stretch it. Very good. It's going to stretch the data and change what specifically? Does center and spread, do they both get affected? Yes. Center and spread are now bigger. Okay, this is just us kind of making a mental note. That's what they were getting at by telling you that they were multiplying by 4/3. They were taking it through a transformation. So here we go. Question B. What new information about sugar content do the box plots above provide? Are there any conclusions that might be different? Maybe that's what you're getting at there. Are there any conclusions on the front that were different than the back? Remember, look at our medians. In this set, the 1 cup is higher than the 3/4 cup. However, when you look at this, what is the deal? In actuality, what? The median of the 3/4 cup data is actually higher than the 1 cup median whenever you compare them appropriately. Isn't that like a big deal? So, that's the big deal. Here we go. B. The median for the 3/4 cup data is bigger and is actually larger than the 1 cup data median. Okay, and the final question, question C. Based on the box plots shown above, how would you expect the mean amount of sugar per cup to compare for the different recommended serving sizes? Explain. So in the 1 cup serving, so in this top one, where would you anticipate the mean sugar gram intake or value to be? To the left, so somewhere over here is going to be our mean because it is pulled in the direction of the skew. How about on the 3/4 cup serving? Where would you expect the mean on that one to be? Maybe a teensy bit to the left because it looks a teensy bit skewed, but for the most part, it's probably like almost the same as the median. Would you agree with that? So that's very impactful right there. So that says that then the average between those two is definitely different. So I'm gonna write it up here so I can reference the picture. So for part C, I'm gonna say something like this. The 1 cup serving mean is lower than the 3/4 cup serving mean. The 3/4 cup mean. Okay, notice the question says to explain. Basically, how did I come to that decision? So, yeah, I told you the 1 cup mean is lower. Fine. That's probably going to get you partial credit. But you have to get full credit by explaining how you came to that conclusion. And so how could I say that? Okay, good. the skew left of the 1-cup data pulled the mean smaller. However, what about the other one? The symmetry of the other box plot maintains the mean and the median about the same. Agree with that? However, the symmetry of the 3/4 cup box plot maintains the mean with the median. Okay, man, that's hard to read, and sorry it looks like a bunch of jumbled up stuff, but that is full representation that you know what's happening and you know why that is happening that way. Okay, this next question is really actually another graphical display, and we're not going to spend a lot of time on it. I'm just going to kind of show you what's happening here. First of all, you were given a blank page and you are asked to display the data graphically. So you have to come up with in your own mind how you want to display that. Well, here was the hint. Because they're telling you frequencies, that means how many of them. This is middle-aged men. First column is middle-aged men and the flexibility rating that they received. So this says 17 middle-aged men had a flexibility rating of 1, and so on. 70 middle-aged men had a flexibility rating of 5. So that naturally lent me to make this type of chart. This down here is quantitative. That's the flexibility ratings of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then these over here are 10, 20, 30, 40. These are the frequencies. Do you see how I labeled both axes? And so then this number is 17, so I made it go up to about 17. This number was, I think, 29, so 31. So this number was 31, and so on. So then I put those bars up to the appropriate frequency. So I made 2 histograms, one for the middle-aged men and one for the younger men. And so that we want to compare, guess what the next question says? The next question says, now, based on this examination of your graphical display, write a few sentences comparing the flexibility of middle-aged men with the flexibility of young men. So let's kind of just quickly talk through that. You would say, what's the difference in their shapes? The shape of the middle-aged men is, flexibility is more what? More symmetric than the shape of this distribution, which on the young men is more skewed left than the other one. Good. So does it appear as though there's any outliers from the data? I don't really think so, because they're all within 1 to 10 anyway. How about the center? Where does the center appear to be located here with the middle-aged men? It's probably somewhere in the 5 to the 6 range. Where would the center be located with a skewed distribution? Which center would you be more prone to want to demonstrate the data with, represent the data with? With a skewed distribution, should you use mean or median to represent the center? Median. And the median is probably located about in here somewhere. So what do you have to say about those 2 centers? The young men's center is probably a point or 2 higher than the middle-aged men's center. What about the spread? They're about the same, because they're all 1/10. So there you go. Very good. Next. This is a reference of what we learned on Monday. It's a review problem, and so I want you to have a very good grasp of what a point on this chart means. This is very important. So let me read it to you. A large regional real estate company keeps records of home sales for each of its sales agents. Each month, the company publishes the sales volume for each agent. Monthly sales volume is defined as the total sales price of all the homes that the agent sold during the month. The figure below displays the cumulative relative frequency. So these numbers are adding on to each other. And it's relative, so that means it's in what? Percents, not counts. Okay. It describes that in terms of the most recent monthly sales volume and hundreds of thousands of dollars for these agents. So, first question is, what does this circle point mean in context? This point is 3, 0.4. I want you to write down on your paper what this point 3, 0.4 means in context of this problem. Do that now, and we'll check. So what did 3, 0.4 mean? Nope. Yeah. They didn't sell at least $300,000. Oh, you said at least $300,000 or less? Oh, okay. Or at most $300,000. Okay. 40% of the agents sold $300,000 a month. And here's the thing you would get wrong if you did not have it. And if you did not have these next two words, you are missing the whole entire concept of this graph. Or less. Okay? If you do not have or less, then you do not understand what this graph is representing. Okay, question B. Yeah, that would probably work. What proportion of sales agents achieved monthly sales volumes between 700,000 and 800,000? So that's in this section here. How many were in this box? How do you know that's 10%? Because that's 80% minus the 70%, so that makes 10%. C. Hey, this is interesting. Look. Between $1 million and $1.1 million, this line is flat. And why is that happening? Correct. There was nobody that sold in between $1 million and $1.1 million. Nobody sold in that area. So the cumulative total remains the same. Finally, a bonus is to be given to the top 20% of agents. What is the monthly amount of sales volume that the agent must achieve in order to qualify for the bonus? So where's the top 20%? Okay. Here is the top 20% here, which is 800,000. Oh, sorry, I drew that wrong. Maybe. So that's here. There's the top 20%, 800,000 or higher. So this one is 800,000 is the minimum. 800,000 is the minimum. Very good. Now, look at your homework, which is a packet, because I don't want you to do all of it. Oh, Oh, shoot. That's the announcement. Oh, you do the multiple choice section. Just the multiple choice numbers 4 through 21.
I pledge allegiance to the flag of the United States of America, to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Now the Texas flag. Honor the Texas flag. I pledge allegiance to the Texas, one state, under God, one and indivisible. Please be seated for a moment of silence.
So I'm a Pine Baylor, and they won a letter.